Next, we need to talk about a kind of a peculiar number called e. What is e? Well, the number e is defined as the number that the expression 1 plus 1 over n to the n approaches as n goes to infinity. In other words, e is defined to be the limit as n goes to infinity of 1 plus 1 over n to the n power. And this is an odd number because it's irrational, like pi or square root of 2. So you can't write it down precisely as a decimal. If you ask your calculator what e is, you'll get an approximation. And that approximation will be just slightly larger than 2.7. By the way, if you take a look at Table 2 on page 310 in the textbook, you'll see a chart where they plug in higher and higher numbers for n, and you can see there how as n gets bigger and bigger and bigger, this expression 1 plus 1 over n to the n power gets closer and closer to something that's just a little bigger than 2.7. This is considered to be the natural base for the exponential function. And so when the exponential function has base e, we call it the natural exponential function. Let's see what the graph of the natural exponential function looks like. First of all, before we even jump in, let's notice that the base that we're using on our most basic natural exponential function is just e to the x, and the base on there, what we were calling b before, is bigger than 1. So we said e is approximately 2.7, so that means that e is bigger than 1. So I should be expecting a graph that looks like the exponential graphs we did before, where the base was bigger than 1. Let's make an xy table and see if that's what we get. And I'm going to use, let's say 2, 1, 0, and negative 1 for my x values. If I ask my calculator for e squared, I get approximately 7.4. E to the first power is just e, and we said that was approximately 2.7. Anything to the 0 power is 1. And when I ask my calculator for e to the negative 1 power, I get approximately 0.4. Let's plot those. So we have 2 and 7.4, so that's roughly 7.5. Then we have 1, 2.7. Then we have 0, 1. And we have negative 1, 0.4, so roughly a half. And sure enough, we get something that looks like what we expected. The base is greater than 1, so it's going uphill. It goes uphill very steeply to the right, levels off and gets close to the x-axis on the left, and goes through 1 on the y-axis. So this is one of the basic exponential functions, and as I said, it's considered to be the natural one in calculus. And you might wonder, what is so natural about using this weird number as the base on our exponential functions? And I guess the answer I'll give you guys is that in calculus, all the formulas we use with exponential functions are easier and simpler if you stick with base e. So even though, say, using like 2 to the x or 1/2 to the x might seem more natural, the formulas in calculus are actually harder to deal with if you do that. So we pretty much stick with using e as the base of natural functions in calculus. So let's build on that. Let's look at the graph of f of x equals 2e to the x. What's that going to look like? And again, I'll use 2, 1, 0, and -1. So if I ask my calculator for 2 times e squared, I get about 14.8. If I ask my calculator for 2 times e, I'll get about 5.4. Anything to the 0 power is 1. So when x is 0, I'm going to have 2 times e to the 0. That's 2 times 1, which is 2. And last, if I ask my calculator for 2 times e to the -1, I will get about 0.7. Let's plot those. Let's see. So I have -1, 0.7. I have 0.2. I've got 1, 5.4, so that's about 5.5. And then when x is 2, I'm actually off my coordinate system here. Let me just try to estimate that, though. Somewhere about there. And we get a similar shape as before. It's just a little exaggerated vertically because of multiplying all the y values by 2. But something I want to point out here is that the y-intercept is different. So with our just basic exponential function, the y-intercept is at 0, 1, which is what we said it would be. But over here, notice our y-intercept is at 0, 2. And that's because we multiplied all of our y values by 2. So when we put in a 0, remember x equals 0 is putting in x equals 0 is exactly how you get the y-intercept. Well, putting in the 0 gives us the 1, but then I also have this 2 in there. So the principle here is that this constant coefficient on front of your exponential is actually going to be what the y-intercept is.